This is Chapter 10C, Types of Factors and Designs. So there are different types of factors used in ANOVA. You've noticed probably that we have some factors that are participant factors, or variables that are internal to a person, just measured to form the basis of groupings like gender, personality traits, age category, ethnicity, etc. Some which are situational factors or conditions in which an individual just happens to be placed, like school A versus school B or different neighborhoods. And then we have manipulated factors, factors that are part of the experimental paradigm and are often randomly assigned by the researcher, like success-failure feedback, interventions like meditation or therapeutic techniques or educational approaches, etc. And if they're randomly assigned, they're true independent variables. So sometimes we have to dichotomize variables in order to make them useful in ANOVA. And by dichotomizing, we just mean dividing a continuous variable into nominal groups for inclusion in ANOVA. So for example, sometimes we might have a continuous age variable. We've collected people's ages, but we might group them into older and younger for the purposes of analysis. Or maybe traits. We might group people into low or high levels of a trait, as was done in the sensitivity variable at the start of the chapter. And you might recall that that was the situation where they handed out easy and difficult tests to both high and low sensitive people to see if it had an impact on mood. So typically, if they're going to do this, they're going to dichotomize it and they're going to sort of get rid of the people at the middle levels of that variable and use only people who are at the highest and lowest end of the trait. So the people with moderate levels won't be included in this particular study. And the reason they might do that is it allows for greater distinction of the impact of the trait. If we include the middle people, the effect would be blunted. We also have within and between subjects variables, and it actually relates to the design of the study. The variables themselves could be conducted either way. So let's take a look at what this means. So designs differ by whether they use repeated measures, paired data, or not. And if you're thinking this sounds a lot like the paired samples t-test, you'll be correct. So repeated measures or paired data just means variables for which each individual produces multiple scores, like before-after data. Just the kind of thing we talked about in the paired samples t-test. And so an example might be treatment type, meditation versus exercise versus control condition on stress. And if we decided to approach this in a within subjects way, each participant would provide stress data after each condition. And this would be called a repeated measures design when it's used in ANOVA. Or we could have the very same variable, but we could do it between subjects where different participants provide stress data after being randomly assigned to only one condition. So if each participant is participating in each condition, this is a within subjects design, and it's between subjects if each participant gets only one condition. So you can see we need fewer participants in the within subjects design. Another example, speech rate, slow, moderate, and rapid speech rate on heart rate. So within subjects design, each participant's heart rate could be measured 3 times after listening to broadcasts delivered at a slow rate, a moderate rate, and a rapid rate. We could also do it as a between subjects design, measuring heart rate for different participants who were randomly assigned to listen to one broadcast delivered at a slow, moderate, or rapid rate. When we describe these designs, we describe them as completely between subjects, which means each individual experiences only one level of the factor. And incidentally, all the examples in this whole chapter 10 segment that we're doing this week uses between subjects designs. I haven't given any within subjects. And we can tell it's between subjects because no individual is in multiple levels of any one factor. But we could also have a completely within subjects ANOVA, a design in which each individual speech experiences every level of each factor. And then we could have a mixed design, a between and within subjects ANOVA, a design in which one or more factors is between subjects and one or more factors is within subjects. So we can have one study we want to conduct with many possible ways of doing it. So let's imagine that we wanted to study the effect of fasting hours, 8, 12, or 16 hours in a 24-hour period, and water consumption, normal, what a person would normally drink versus high on metabolism. We could do this as a completely between subjects design and take a large group of individuals and randomly assign them to one water condition and one fasting condition, and then measure metabolism in some way. Or we could do it completely within subjects and assign a group of individuals to provide data after each combination of water and fasting, meaning they would, they would just do each combination uniquely, and then each day they would provide the metabolism information. Or we could do a mixed design between and within subjects. Individuals would be randomly assigned to just one of the two water conditions, either normal or high, and they would apply it each day of 3 days of fasts lasting 8 hours, 12 hours, and 16 hours. And so you can see that it's up to the researcher to make the decision about how they want to approach it, and you'll see all of these when you read studies using ANOVA. So how do factor types determine level structure? In other words, which variable should be first when you're describing your ANOVA design in terms of your levels, like a 2x3x2 ANOVA? So some rules of thumb: between subject variables precede within subject variables, typically. Participant variables precede treatment variables. Variables that come first in time precede variables that come later in time. So if you have a study in which the effects of gender, self-care practices, and water consumption, and you could have, and let's imagine that self-care practices is between subjects. There are 3 methods randomly assigned to individuals, but water consumption is within subjects. They have 3 levels on different days, and maybe anger is what's being measured. Well, in this case, you would want to list gender first. It's participant variable. It's also first in time. Self-care practices might be second because it is between subjects, and water consumption could be third because it's within subjects. But these are not hard and fast rules, just guidelines. Different people might advise different things. So one last thing is, this is actually a really important last thing. We've been describing ANOVA in terms of factors and levels, like describing this little grid here as a 3x3 ANOVA. 3 levels and on factor A and 3 levels on factor B. So a 3x3 ANOVA yields 9 combinations, as you know. You multiply 3 times 3 to get 9, and you can also see why in this grid. And so that means that each participant could be in any one of these cells, any one of these 9 combinations. And we refer to these combinations as cells. So this can be, you can imagine this grid in your mind's eye. But now note this: each cell represents one possible interaction effect. So each one of these is combining 2 levels of these 2 factors, and that's a potential interaction. So that means that there are 9 possible interactions here in this design. So each cell is going to represent one possible interaction. Each factor would represent one possible main effect. So a 2x3 ANOVA has 2 possible main effects because it has 2 factors, and 2 times 3 equals 6 possible interaction effects, 6 cells. A 3x2x3 ANOVA has 3 possible main effects, or 3 factors, and 3 times 2 times 3 equals 18 possible interaction effects, 1 per cell. And that right there is the end of this lecture.